Okay, these are the tension problems from the yellow worksheet. I'm gonna go through them kind of quickly and I'll post a video and you guys can go back and watch whatever you want. This is 2 masses over a pulley, number 1. 7 kilos and 13 kilos. So if you're mathy, what you want to do first is you want to decide which way is positive and which way is negative. Which one of these is going to go down?
13.
13 is going to go down and 7 is going to go up. So I would make this side positive, so everything moving that way is positive, and everything moving this way is negative. This is weird, right? Because they're both down, but we make this one positive and this one negative. If you want to straighten it out and draw it like a tug of war, you can do that too. Okay, so let's label our forces. If we're going to be quick, this, we would say this is about 130 newtons. Technically it's 13 times 9.8, but we're going to round 9.8 to 10 so it's quicker. If you use 9.8, that's totally fine. Your answer will be slightly different than mine. No worries at all. And this is going to be how much over here?
70.
Good. This is 70 newtons there. Now, this is negative. So if it helps, if you're like, I always get the math wrong with 3 at the end, put the negative there on the negative side. The first thing we want to do is we want to find the net force of the whole system, because we can use that to find what? What's the key to all this problem? Acceleration is the key, right? Because that's going to be the same for each mass. So, we start with the net force of the system. And that's the sum of all the forces. Now, we also have tension forces here, right? But normally I tell kids, you don't even have to draw these in. How do I get away with not drawing those forces? Sean?
They're going to cancel each other.
Good. They're going to cancel because even though they're both up, this one is negative and that one is positive. This negative, positive. That makes more sense if you flatten it out. Okay, so this is going to be this Fg plus that Fg. So it's going to be 130 newtons plus negative 70 newtons. And that means our net force is 70 newtons, right? No, 60 newtons, sorry. 60 newtons in the positive direction. That makes sense because it's going to go this way, right? How do I find the acceleration from that? Hardisher.
You divide F0 over the total system mass.
Great. So I'm going to take the F net for the system and divide by the total mass. I have to make sure this is the total mass because this is the net force of the whole thing, not just one mass, right? So this is 60 over, what's my total mass? 20, that's nice and handy. So this is 3. And that is my acceleration, and I encourage you to draw a little squiggly thing around it because that's what's going to be the same for this block and for that block. Okay. Let's do, I'm just going to do a little box around this part. Let's find the net force on the 7, and we'll find the net force on the 13. Kefe, how am I going to find the net force on the 7?
F3 times 7.
Yeah. Very good. Give him a golf clap. Because the 7 accelerates at 3, right? So this is MA. But now it's not the total mass, it's just the 7. Because we're looking for the net force just on this 7. So 7 times 3 is 21. And that's going to be positive 21, right? Is it? Yeah, that's right. Okay. Net force is MA. What else is net force? Remember I said there were two things last day.
Oh, sum of all the forces.
You had the sum of all the forces. Okay, so the net force on the 7 is going to be the net forces on this block. But now you have to you have to say, now I'm not looking at the whole thing. I'm just looking at this block here. You have to focus in on that block. So what are the two forces on this 7?
Tension and gravity.
Tension and gravity. Good. So this is Fg and Ft, and if you're mathy, you just add them up. It always works. If you're real worldy, you're not going to do this. You're going to say, well, that one wins, and it wins by this much. So this plus that is going to give you the tension force. And you don't worry about the negatives if you're real worldy. Technically, this is more correct. Both ways work fine. Just depends on how you're thinking about it now. We got to solve this Ft, so we're going to subtract our Fg over, and that will be Ft. And so we're going to say this is 21 minus negative 70. And that's going to be 91 newtons. So that's my first tension. If you had to guess, what do you think the tension over here is going to be? Very good. Give Sogan a golf clap. Negative 91. But let's prove it. Let's prove it to ourselves. This is MA as well. But which mass do I put here? Rocco? This is going to be the 13. So how do I find the net force on that 13? Close. So if I cut the string, this would accelerate at 9.8. And that's how I get my gravity force. But is this going to accelerate at 9.8 when it's tied to the other mass? No. What will it accelerate at? Yeah, 3. So I'm glad I got you there. Stefan, how do I find the net force on this 13 kilo mass? Say it again. I think you said it right, but I didn't hear you. 13 times 3? Is he right? Yeah, that's right. Good. So we do our just the 13 now, and we're multiplying it by the 3, which is our acceleration. So don't get confused. The acceleration of gravity is 9.8. This system will not accelerate at 9.8 because they're pulling against each other, right? So that's why we did all this business, to find out the actual acceleration. You use 9.8 to find the force of gravity, but that's not what this thing actually does. What would I have to do to make these blocks accelerate at 9.8?
Cut string.
Exactly. If I cut the string off, they'll both fall at 9.8. But because they're over the pulley, now they're working against each other, and it's a tug of war.
Is it mad if you cut the string on the opposite or like you have to start in the
Oh, that's a good question. I don't think so. But in reality, it would. In reality, if I cut it here, this one would go a little bit slower. Tell me why.
The weight of the string.
Yeah, this string actually has weight, and this has friction in the real world. But in physics 11, no. Exactly the same. Because we're not worried about our strings. We have these special strings that weigh nothing. They're like, it's like nothing. No friction ever. We'll do that later. Okay, so 13 times 3 is 39, right?
Yeah.
So that's my net force on the 13. And then I'm gonna go and do this, and this is the same. This is Fg plus Ft, because that's the two forces acting on the 13. But this Fg is different than that Fg. So we're gonna say F net on the 13 minus Fg should give me my Ft. It's kind of the same thing, but this one is 39. And it's minus this one. Is this 130? Is that positive or negative?
Positive.
Good. This is going to be positive, so we keep it positive. And if you take a look, what's the answer?
91.
Negative 91 newtons. And that's going to be the FT on the other side. So, are we right? Yes. How do we know?
Because we got this one.
Got the same. So this is the negative 91, and that's the positive 91. If you get an answer and they're super different, what does that mean? Means either physics is broken, which I'm still waiting to happen. It could happen, but it hasn't happened yet. Or you made a mistake. So if you get these two, if these two are like close, if you get like 90.8 and 91.3, like if they're just a little off, that's fine. It's just a little rounding difference. Okay, good? That was number 1. If you want to take a picture, you can. It will be on the video too. Should I do number 2?
Yes.
Number 2 is the table one. This is a table. Is there friction on this one?
It's frictionless.
No friction. Okay. Yeah.
Can we do 3 because if we can do 3 then we can do 2.
You want to do number 3? Like not this one? Let me do this one really quick, because some kids will want it. I'll do it super fast, okay? And then we'll go on to number 3. Okay, so what are the masses here? M1 is the hanging one, and that's 20. And this is 10. Okay. This is going to be... Oh, I hit the rim twice. This is going to be 200. And there's no friction back. So the net force on the system is just 200. Because there's no opposing force. And I'm going to make everything this way positive, and everything that goes backwards negative. So I go 200, I'm going to divide that by my total mass, which is 30. And that's going to give me 6.8 something something. Does anybody know what it is? Is it really? Is it 67?
6, yeah.
Okay, it's 6.7. Everybody with me? Oh my gosh. You know it's bad when the physics teachers do it. Okay, so now we're going to do the net force on this mass and the net force on the other mass. The net force on the 20 is going to be 20 times 6.7. That's like
13.4. 130.
133.3 repeating is what I got. And that's going to be positive. And on this one is going to be 10 times 6.7, so pretty much 67, but it's 66.6 repeating. I'm just doing a little bit more so we can get the exact number. And then we do the same thing here. I'm going to skip the first step because it's the same as it was before, right? The net force equals Fg plus Ft. But we subtract over, and this is going to be, so this is going to be 66.6 minus, minus nothing. There is no other force, so we don't even need this. Maybe I'll put 0. Minus 0. So the Ft is going to equal 66.6 repeated. this one, if we want to confirm, oops. This is going to be 133.3 repeating minus that, which is 200. And that should be 66.6 repeating too, right? But negative. If you got 67 for this, or 66 or 65 or whatever, that's fine. And this is the FT on the other side. So we got those two the same, and that's great. Does that make sense? Yes, Julie?
Don't you do 200 minus 132 if you get negative? Oh wait, never mind. Sorry. I don't know why I thought it was 300.
That's okay. Makes sense? Everybody good with these? Okay. I did this fast, so if you watch the video and you want to slow it down, just you can go back, I'll post it on the classroom.
Wait, what if it's not frictionless? Like part C, I think it says
Ooh.
there's a force of friction of 40.
Okay. Let's try it with friction. I'm gonna leave everything the same except for the parts that will change. How much is the friction, Iman?
40 newtons.
Okay, so this is part C or something?
Yeah.
Okay, so if there's friction, this is a great question. There's 40 newtons back, that's gonna be a friction force. If that's suddenly there, like in the first part there was no friction. Now if there is friction, my net force on the whole system, is it the same or different? It's different. How much is it gonna be?
160.
Good, 160. This is pulling 200, but the friction's pulling back 40. So this is gonna be now 160 newtons. And so now you do 160 divided by 30. And that's gonna be 2 and 3 and 5.1, 5.3 repeating. So this is now my acceleration. You put this here, and this is gonna be about 53, 53.3 repeating. This one is gonna be 106.6 repeating. And we're going to, this is gonna be 106.6 repeating. Because this is 5.3. So we still do the same. You just multiply each mass by the acceleration, you get the net forces. But in this case, the net forces are different now because we've got friction pulling back. So it's gonna end up a little different. This stays the same though. The net force on that block is still Fg plus Ft. So subtract the Fg over. So this net force is now 53.3. Then you minus the, actually that's not gravity anymore. This is friction now. Because now there's an extra force of friction pulling back. But we can just subtract that, and that's gonna be negative 40. And I probably should have, if I'm mathy, I should have said that from the beginning. That this is, because this is all negative, this is going to be negative 40 newtons. Okay? If you're mathy, you really want to slow down and ask yourself if it's positive and negative. So this is going to be 93.3 repeating, and that's going to be positive. This net force is now 106.6. And so this is going to be now negative 93.3 repeating, something like that. So we still get the same answer. Does it make sense?
Yeah.
Sort of. Everything is kind of the same. The only difference is really this one. That's 160. Sam, what are you thinking? Are you good?
Why don't we count gravity for this?
For this one?
Yes.
You could.
We have if normal, so it's fine.
That's absolutely correct, Kurosh, yeah. Really, technically, Sam, you're right. to find this net force, we should say there's Fg, but there's also Fn. Those two are the same, right? So we really should be saying, oh, and there's Ft here as well. And this has Ft. And it's not a bad idea to draw these all out, especially in the beginning, just to tell yourself, this is all the forces, we can account for them all. This one on the 10 is going to be Fg plus Fn plus Ff plus Ft, right? What do these add to?
Equals 0.
There's a 0, so they're gone. So you don't really have to put them in.
Oh.
If you know that the two are canceled, you can leave them out of your equation. I understand that you understand that. Okay, are we good for number 2?
Yes.
Okay, I'm gonna stop the video, I think, because if they get too long, they bung up my YouTube channel. Okay, I'll start with number 3 in a second.